So our journey begins with the partner prerequisite survey. Here is an example of that. It asks for some basic information such as the partner name, commercial contact, technical contact, and the list of ChatOps WebEx contacts. This gets passed back to our Mesi engineer, who then creates a partner service definition file. In this example, we're going to create the cloud layer. This then gets committed to the code repository, which in this instance is GitLab, and that creates a merge request. So you can see here, this is our merge request. We have one file that's changed, and this is to deploy the cloud layer. You can see here we have the customer ID, which is the unique reference for the customer on the platform. We also have the customer name from the prerequisite survey, along with the customer contact and a list of ChatOps users. What we're going to do is I'm just going to self-approve this for demo purposes, so I'll just approve that. And then we're also going to keep the source branch and squash commits. So let's go ahead and merge that, and we'll see our job kick off. Excellent. So we can see that's merged, and we have a job queued. You can see our job is now running. Pause that because this can take a second. Excellent. So that's completed successfully. So what that's done is that's executed our service plugin, which has communicated with various different APIs to get this cloud layer set up, ready for the infrastructure layer. As an example, what that's done is it's created our Cisco WebEx space. So this WebEx space is used for all the notifications from the platform. It's also used for other things like communication and support with the partner. As you can see here, it's created those added those 7 Cisco IDs that was part of the JSON definition file, which was populated from the prerequisite survey. For submission purposes, we've skipped the infrastructure layer, which also includes the network configuration and the platform layer. We will start to deploy the POV deploy layer now to show you how the partner is informed when their codified Cisco proof of values are deployed directly to their platform. Let's head over to GitLab, where we have our change request. So you can see we have one change here, which is to deploy the POV deploy layer. We're deploying version 1.0.11 of our proof of value catalog to the partner's platform. So all of our catalogs are tagged with the version, so we can deploy any version at any time. Let's go ahead and approve this and merge the change into our production branch. Excellent. So you can see that the job has started. And if we look at our Cisco WebEx room, the partner has been notified that the POV catalog is being deployed along with the version number. This takes roughly 20 minutes to complete, so we'll pause the video here and get back shortly. So our final layer has been deployed successfully, and the platform is now ready to be used by the partner. Before we execute a proof of value, we'll quickly run through some of the different components and tools we have used as part of this deployment. Let's first head over to Terraform Cloud that has been used as our infrastructure as code solution. The plugin we mentioned earlier has manipulated the Terraform Cloud APIs to dynamically create the workspaces that are required for the deployment. This also includes populating variables, including secret variables from HashiCorp Vault. This is our HashiCorp Vault that you can see the secrets have been organized by the unique customer reference we mentioned at the start of the video. All of the passwords have been dynamically generated and stored directly in the vault. We also use short-lived access tokens throughout our infrastructure as code framework. Our plugins also communicate with Netbox as our IP address management solution to ensure that IPs are allocated correctly. We can easily track IP address allocation. As you can see here, for example, the platform's DHCP server is on IP address 10.22.164.62, and it's on the VM network. As the platform is deployed, we integrate monitoring using Prometheus and Grafana. Here is an example of a monitoring dashboard that has been dynamically created via the Grafana APIs. This is an evolving dashboard as we continue to add more component monitoring to the platform. As we saw earlier on our IPAM solution, we deploy a DHCP server to the platform. This uses Terraform to deploy a basic Ubuntu image from our binary and image repository that has been copied to the platform. We then use Ansible AWX to install and configure the DHCP role. If we head over to Cisco Intersight, we can see here that all of the automatically provisioned UCS and Hyperflex servers have been claimed into Intersight via the wide range of Intersight APIs. We also have some other targets programmatically claimed during the provisioning process to support the proof of values. You can see here that we have used the APIs to create the policies and profiles to assist with the automatic provisioning of the UCS and Hyperflex servers. Now that our Solomon platform has been deployed successfully, the partner is now ready to start launching the codified catalog of proof of values. This is an overview of the Solomon architecture. The journey starts off with the proof of value artifacts that have been copied over to the platform. If we look at the GitLab instance that was deployed, we can see that there are 5 projects that have been automatically created and copied over to the Archie platform. Inside the templates project, we have our catalog of available proof of values, capacity planning, custom performance optimization, and background activity. When the platform is deployed, the partner is sent a link to the wiki page. This is completely and dynamically created for the current catalog of POVs on the platform. This includes the human readable artifacts. Let's scroll down and have a look at our partner user guide for cost and performance optimization. The partner user guide is the detailed guide that assists the partner with the full end-to-end process of the proof of value, launching the POV, demonstrating the POV, and terminating the POV. Let's go ahead and launch our custom performance optimization POV. For each POV, we have created an Insight Cloud orchestrator workflow that reads the service template file and commits it to the GitLab instance on the platform. This then has a dedicated service plugin that will provision the resources using the various tools deployed to the platform. This will also talk to various APIs such as Cisco Intersight and Cisco WebEx. All of the secrets are stored on a deployed instance of HashiCorp Vault. To execute a workflow, it's as simple as entering the service name, service description, and service owner. We then click Execute to initiate the workflow. In the background, this has committed a file to the services project, triggering the CI/CD pipeline. The partner will also be notified via the Cisco WebEx room on the status of the POV. Let's skip ahead to when this will be completed. The partner has been informed via ChatOps that the POV is now ready to be demonstrated to the customer. We can see that our service plugin has deployed a Rancher Kubernetes cluster and claimed it into Intersight to showcase IWO's ability to monitor and provide recommendations on the Kubernetes cluster. Our partner user guide will aid the partner on discussion points about the different Kubernetes entities, along with some additional IWO features such as groups and placement policies.